Thank you, Tom. I don't know if it was the year when you were at CoFace 1 year day, challenged the audience to come up with alternate meanings of the term CoFace. And the one that resonated most with everybody was the Conference of Fat Engineers Schmoozing. So, but now it's a fun event, and it was indeed great to meet Tom. And thank you, Tom and Synchro team, but also NTI for bringing us all here together. And maybe more importantly, for giving us tools that allow us to build better. Because in the end, I think that's what we are all passionate about, building better buildings in better ways. And without new tools, it would be hopeless to do that. And that has really also been the motivation behind my work at Stanford. And thank you for the invitation to present on the past, present, and future of 4D modeling. I'm going to try not to dwell too much on the past, but I guess give an indication. I'll share a few vignettes from a few years back. And then actually I will talk more about the future, less about the present, because we have many speakers who are working in the present who will give you a very good view of the present. So as Tom said, I'm a professor at Stanford, and I direct also the Center for Integrated Facility Engineering, which now for almost 30 years has done research around how do we integrate facility engineering. And that's the, thank you for the introduction, conceptual setting laws. Hence a number of the frameworks that we have put together that you may have seen. And because without those frameworks, we can just create anecdotes and stories. We can't really integrate in fundamental ways. We can't create the synergies that allow us to build better, faster, without integration. And we cannot use computational methods if we don't have sound frameworks. But I won't dwell too much on the frameworks here, but of course, I'm always happy to talk to you about those. We did a lot of work in BIM in the early days, in the late 80s and 90s. Then we developed what is now, what we branded as virtual design and construction, really a work method, project management method, to leverage BIM and other emerging methods. And now we are really focusing in our work on how do we optimize the performance of our buildings. So it's not a talk about VDC, but 4D modeling is a way how I personally came to VDC, because we saw the benefits of a unifying visualization that brought many disciplines together, combined with information that really hits at the core of what every project focuses on, the product and the process of what we build and how we build it. And so we realized that we needed, of course, those tools, product modeling, BIM, but that had to be part of a rethought process, of a rethought digital and physical production method approach, which had to support really the knowledge of the people, bring them together, the different disciplines, the different knowledge bases that we all have. When we bring those together in a coherent fashion, simultaneous fashion, we have seen amazing results. And I know many of you have experienced that, and I guess I should have said in the previous slide, it's fantastic to see many supporters, many of the members here today. And of course, that all won't amount to anything. It's just effort if we don't meet or exceed what the project should achieve and what the client really wants. But for me, 4D modeling was really the way to realize that we needed this kind of method to manage projects. So I wanted to start by briefly sharing why, in my mind, 4D modeling is fundamentally important for construction. And I'm a little bit puzzled that, I know I'm preaching to the choir here, but that many of the colleagues we have in the industry don't seem to see this perspective. Because at the end of the day, we in construction get paid until we change our business model, but for the time being, we get paid for delivering a product, a building, a bridge, what have you. That's the value we add, that we create that building, that bridge, It's just something the client wants. Again, you can imagine a different business model than that, but from now, that's what we get paid. That's the value we add. So that's the product. And we do that by applying all kinds of work processes. This is the effort, this is the cost that we incur to deliver this value. And you see, you can already see here, right, 4D is really time plus 3D, or process and product together, or really the cost and the value together in one model. And this is really the core we do. And so it's a bit surprising that not every single project in the world today uses a formal 4D model because, as I said, this is the core of what we do. So, but I understand, I preached it prior, but this is for me the gist of why 4D is just so fundamentally critical for our industry if we mean to provide value productively or efficiently. And I'm also surprised by still how many models we use that are static. They're like, you know, a slice in time. We analyze a slice in time. When things are really only interesting because of time, because of things changing over time. And again, that's of course where 4D shines, bringing that perspective to the project team. As many of you know, I'm not a big fan of the other terms 5D, 6D, XD, ND, mostly because I have to live with scientists that are my colleagues when I see them for lunch. And they're going to ask me, what the heck, Martin, is XD or 5D even? And I understand it's convenient terms, but we should not forget that 4D are really the only dimensions. And 5D, like cost, and 6D, whatever else it might be, are results of our decisions around that can be represented in the 4 dimensions of X, Y, Z, and time. So we should mix dependent and independent variables. The 4D is the independent variables, so things we can decide to do. We can decide to do an activity or not do it. We can decide to build this space or not. The result is then a certain cost and many other performances like Klaus has said it. So, but anyway, just a quick side note why you see me more focused on 4D. Because we want to improve cost, etc., but it's not a dimension. All right, so I want to take you, Okay. I want to take you through a few quick examples, early experiences in 4D, then talk about really where I see things going, and part of it I labeled as back to the future because it's some work we did quite a long time ago that I think is still timely, and hopefully the future will bring those functionalities, and then also talk about what I see is next, talk about some of the recent or ongoing research. So personally I got into 4D modeling really by seeing one of my first jobs, working on the James Verrazano Bridge in Rhode Island for VSL, the tight connection between product and process. You couldn't really design this bridge unless you knew how to build it, and vice versa. And I felt at the time that the representations that were used, that were the basis of everybody's work, were really not good enough to create a good design quickly. When I went back to Stanford to study, I was introduced to Buddy Cleveland, who really for me was the person that showed me, well, he showed me the first 4D model I saw. He was working at Bechtel in the R&D department, and he led a team that created a tool that's called Construction Simulation Toolkit. In 1987, he would show you this 4D model of this power plant for Hitachi in Japan. And I thought, wow, this is pretty cool. And then a few years later, finished my PhD and was an assistant professor at Stanford. Jack Ritter, the vice president of Building and Construction, walks into SciFi and says, if you're worth your money, you can help me on this project. I have a problem with the renovation of this hospital project that I need to do while it's fully operational. And then after saying, well, we are not consultants, we are a research organization, we thought, okay, this is a really interesting problem, so we got into it and we are very happy that we did. That was the first 4D model that we were able to really work with a project team, and it really inspired the style of research we've been doing ever since then at SciFi. We work with George Hurley very intimately, day to day. The challenge they had is that they had to renovate and extend the hospital from the state on the left to the state on the right, while the hospital was fully functional. And the client needed to say, I want to understand the construction schedule and we want to make sure that it doesn't affect the operations of the hospital before I give you the green light. And that just went on and on and on for months. Because the client said, well, I'm not sure, you have not really shown me that construction and operation can really function side by side. And so that's where we felt the 4D model would be a good solution. It turned out to be. It was, the schedule was pretty good, it turned out, but there were definitely a few time frames when some adjustments had to be made. And so this was our first experience. And so we thought, wow, this is super cool. Even though it was horribly expensive, we had to buy $50,000 worth of hardware and software in $1993. Imagine going to project team today with that bill for something very experimental. But we easily paid back very, very rapidly. So we thought, okay, this is super cool. Within a few years, like Lars said, most projects will work this way. So we shared this with others in the industry, and the story we heard, oh, this is very interesting, Martin. But I understand that on this really complicated project, renovating a hospital while you use it, yes, I can see they need to use this tool. But my projects are not this complicated. So I'm fine the way it is. So then we went to the other extreme. We did, the next case we did was the roof of the Hospital of Business in Berkeley. The team had never come together, the different subs and the GC never come together around a clear sequence of that work. And as a result, they wasted several $100,000 just on putting the roof together. We worked with the roofing company and we were able to show with 40 hours of 3D and 4D modeling work what the best sequence would have been and the cost of the sequences they had to do. Here are just a couple of illustrations. And so we thought, okay, now we've shown that this works on a really complicated project and is valuable on really simple projects. Still, that didn't seem to be enough to really get things going, because as you see, this all happened in 1994, 1993. By the way, he was the only guy, the only subcontractor that got a claim paid from the general contractor on this project. So I think it was worth it. So we were able to then get into some more complex projects with Disney, and here with the Concert Hall Los Angeles with Frank Gehry, and a few other projects where we kind of could extend the applicability and value of these models. For example, here on the Concert Hall, there were many 4D models built. This one was used, a model like this was used every month. Well, let's not waste time. I assume we'll share the slides and I'll add the link, and it should work online. In this particular case, the model was used, the one I was going to show was the subcontractor coordination model that was used every month to make sure that everything was in place for the work to take place. And there was equipment between the subcontractors and each other that they were going to really follow the schedule, which actually happened. The model was used for many other purposes, such as, for example, in an afternoon we were able to plan in a virtual reality cave, again this was in 2000, how to cut 6 months out of the schedule and get everybody on the same page. And get the project executive to cough up $250,000 on a fixed price or guaranteed maximum price project to make it possible. So nobody had really looked forward to going to the project executive and saying, you need $250,000. And by putting everybody together in the cave and everybody being immersed in the space, they could all agree on the approach, which included putting what they call the dance floor into the building so they could work below on the seating area and above on the ceiling. Which of course was at a cost and required quite a lot of coordination. But we were able to essentially do that in an afternoon with the project team. We used the 4D model to very rapidly iterate with the foreman on a project that was under extreme time pressure, a shopping mall project near Berkeley. to help them cut 2 months out of a 16-month schedule because of foundation delays. And nobody had taken the project at 16 months, just this one contractor, PPL, and now they had 14 months, which they thought was really crazy. But they were able to get it done in part because of the 4D model, because it showed very clearly, for example, here, areas where you had finished work, but then you weren't really doing anything for weeks. So this highlighted opportunities very quickly to the project team to do work there and possibly accelerate the schedule. So we had, over a 2-week period, every lunch time with the foreman in the trailer, but every lunch they had ideas of what to do. And then we implemented those suggestions, came back the next day at lunch, and showed them, remember you had this suggestion, remember you had this suggestion. They said, look, this is good, this is bad, because nobody can really foresee the ripple effects for the whole project. But this was an extremely productive period to get the best schedule developed and to get everybody to buy into the schedule and believe it and then follow it. So the last example I want to show here is an attempt we had with a concrete subcontractor to take it to the daily level. This was about 2006, 2007 maybe. And let me see if this video plays. Okay, you can do all the testing you want, and then the system does whatever it does. All right. Not sure why. I thought by having it on Vimeo, this was relatively safe. Okay, but we took the model to the temporary structures to 2-hour chunks. We showed it every morning to the workers in a 10-minute huddle. The challenge was, we kept it up for a while, but the challenge was to keep it up for the whole time. The challenge was the feedback loop from the site to the site trailer. If that didn't happen in a timely manner around 3 p.m., then the 4D model couldn't have the model for the next day ready on the basis of what was really done that day. And then the superintendent couldn't review it at 5 o'clock, and then wasn't comfortable to stand in front of the crews at 6:45 next morning, tell them this is what we're going to do today. So that was just, as a quick aside, the challenge was that feedback loop. I think today we have ways of making that feedback loop happening. And because there was huge value in informing the crew every day and having what exactly they're going to do and what they're not going to do, where and how. So there's lots of these examples. I just wanted to share a few stories. For one, to show you, this is project teams, people like you who have solved problems, real problems on site 20, 25 years ago with these methods. And so it's a well-established method. But I also want to make the point is, don't just create a Hollywood 4D model just because you can. Address a real problem, challenge, risk, issue on the project. Every single application that we have done had a very clear focus of what would let the project manager or superintendent or somebody sleep better on that project. And so here I'm just listing a few of those benefits. And this is, again, something that puzzles me a bit, because if you have time pressures on your projects, and I think most projects have time pressures, if you have space constraints on a project, and again, most projects have space constraints, I don't know how you can really say you have the best schedule and have communicated it to everybody that needs to know it without a 4D model. But again, I know I'm pretty much. So I want to just set the stage a bit. Some of the applications, some of the fun we had with project teams a few years back, and now I want to share a few projects by us and by others that I thought, I guess I shouldn't be gratuitous for the work that we have done, but I thought that was pretty, forward-looking, I guess, if you let me say that. Around interfaces, rapid PDSA cycles, fabrication and construction, parametric 4D modeling, and then metrics about a schedule. So we're pretty annoyed with the 4D modeling tools. I thought this, we're lazy academics. So we wanted to really create something that was much easier to use. And I'll just show a few clips here. So in 1995, after the first 4D modeling experience, I said, oh, this is crazy on the screen, blinking stuff. I mean, this has to be much more interactive. So I was able to work with a few computer scientists, and we put together this, what we call desktop VR, desktop 4D modeling tool. So let me just jump ahead. I'll just narrate it. So it shows a schedule, and then a 3D model of the building, and then all the things you need to build on the left-hand side. These are like 4D work packages, and they know how long they take, and they know where they go. So you see, notice there's no menu, nothing. You can learn the system in 10-15 seconds, anybody, to put this schedule together. So by putting, you're basically building up the schedule, you always see where is the project at when you're making the next step. And then you can adjust, of course, the activities in the schedule as you like, simply by grabbing them. You know, this is 20 years ago, so we had to use laser pointers to grab things, etc. And then you can, you know, rotate, play the schedule back, of course, and you can very rapidly create different scenarios by moving things back and forth or inserting different kinds of work packages. So the challenge here was really the resolution. You see it's a very small scale. The resolution of the system at the time was not that great, but the ease of use of the interface still, I find, is something we should aspire to. I'll make the video available and you can watch it if you like. Another project that I thought was really showing where things are going was a StageWorks project, a StageWorks tool that Bechtel used on the CTRL project, the entry into St. Pancras in London. This was also about 2004 or something. On that project, they modeled, it was very tight because they had possession of the tracks, which they had to renovate while the trains were running during the day. They had possession of the tracks for construction from 11 p.m. to 5 a.m. and they had to do all the construction work in that period and then have the tracks back to full running at 5 a.m. If they were ready at 5 or 1 a.m., I think the fine was 500,000 British pounds. So not something you wanted to pay as a project manager. And so as a result, they had a pretty cautious schedule until they implemented this very rapid feedback loop. They started to model the whole project in 15-minute chunks for the 6 hours. And then they had people in the field with handheld devices. Again, this was 2004, right? I believe. With handheld devices, wireless, updating what was happening every 5 minutes. And then there was a person in the trailer comparing the updates against the 15-minute plan. And was able then to direct the work and say, oh guys, things are not going well, we got to regroup, we got to get things back, or actually you can do more tonight, things are going very well. And with this cycle, they were able to increase the productive use in the possession, and they were able to increase the productivity during the possession. The upshot was something like a doubling of the production, according to my calculation roughly. Mostly, I think, because of this tight PDSA cycles. And the project team told me that, yeah, initially it was a lot of work to set it up, but afterwards, once it was running, it was actually less work than the typical work, because everything was digital. But the planning team, the day shift showed up, they had an immediate picture of what had happened that night, and they could just start the plan. In the previous method, they had to decipher the reports from the foreman that were written up, and it took them till like lunchtime till they had a good picture, and not enough time to really make a good plan for the night. And so they were never really actually, the planning and the execution was never totally in sync. So I'm really actually surprised. I mean, I understand this was a very challenging project, but I'm a bit surprised that we don't have this kind of rapid planning feedback loop on more projects. Another area that is becoming, I think, quite hot now is thinking more carefully about on-site and off-site production. because offsite production is really the only way in which you can multiply your workspace. If you build really fast, like, you will eventually be constrained by the workspace you have on site because you only have one workspace. If the crew is doing something here, that's the only crew that can do something here. But if you can do things offsite, you're in a way multiplying the workspace. So you can really reduce your on-site production time. And this was really quite nicely illustrated by Carsten Springerhoff on a, let's see if this one plays. Okay, maybe I need to reload, I don't know. Let me try this. I'm really a bit puzzled. Okay, I guess I should have reloaded. But anyway, you have seen 4D models before. So here is the Bay Bridge in San Francisco, and the elements of the main span, these elements were made in China, shipped across the Pacific, and then erected. And what this video shows is just briefly how each of those segments was assembled in China. And then what the part I want to show is as then the production of these elements happened, they had this 4D model that showed the work on site here, and then they showed the work happening in the fabrication yard. So you can see these segments are being assembled, these segments are finalized in the lift assembly, and you will see fairly soon. Meanwhile, some work is happening on site. You can see the piers are being made ready. Now these 4 lift elements are on a boat across the Pacific. Now they're being inspected. And then you will eventually see them starting erected here on the site. You still see the site prep work. You see other work happening in the fabrication yard. And now you see these elements are starting to be erected. So you can really see, oh. Ah. Okay, no, never mind. All right, thank you. I get all excited here, but. Okay, so. Yeah, okay, I should just not test anything. I think that it would have worked how it worked the first time that I tested it. So, let's just maybe go back here, or somewhere here. Yeah, so, it's a very, very simple model, but so you can see here these elements are being inspected. The work on site going on, these are on a boat across the Pacific. These are being assembled in China. And then now you see these elements being erected, again, in the work in fabrication yard continuing. So you can really understand on and off-site work. It's a simple model, but it brings together a lot of information that already exists, in many places. But would be hard to put together and to get a common picture by everybody in the project. So I think models that combine offsite, on-site construction are definitely in the future. And then another kind of model that I think in the future is parametric 4D models. We're able to, we developed a prototype for that and tested it on a few projects, but here one we did quite a few years back on the subway station in Amsterdam. Very, very tight site constraints, very difficult excavation. And the challenge was that it was simply too time consuming. It was too time consuming for the project team to play through all the scenarios. So we created a prototype where you could enter the production rate, say we're going to excavate 25 cubic meters per day, and then the 4D model will be produced automatically. The 3D model will be chunked in the appropriate elements. The other activities will be adjusted in terms of scale. And then you could try 50 square, 50 cubic meters, what have you. So you could see what would happen with different production scenarios. So we were able to take the time it took to create a scenario from 2 weeks to 1 day. And in that way, really give the project manager a way to explore many, many more options. So this full parametric 4D modeling tool, I think, should be in our future as well. And the other thing that I think should be in our future that we get, last point to that, use of information. How do we get data about our schedule? So here, we worked on a project at Stanford, a big healthcare project. And basically, as the 4D model was running, we displayed these data. How many cubic meters of concrete are you using? How much earthwork is being done? How much precast is being installed, etc. Whatever metrics you want, we had another one for parking spaces needed and available, and so on. So really, not just see the visual, but get quantitative data about a schedule, and then you can compare different scenarios. You can see which one is better in a more productive way, I think. So I think these are things we did quite a few years back, and I think these things that I just mentioned hopefully are in our future. Easier interfaces, more better connection to data, better connection between on-site, off-site, rapid feedback loops. But there's a few more things that I think that should be in our future as well. I think we can take 4D models beyond construction. We can actually fully automate modeling. We can do data analytics and actually also learn about the scheduling process. So for example, take it into the operations of the building. How's the building working? This is work by Georgia Tech. Fantastic work a few years ago on understanding the circulation and movement in a courthouse between the judge, the defendant, and the public. Really quite a complex situation, and simulating that over time and understanding all of the routes that they take and whether they intersect or not. Really neat sort of this time-based simulation. Or the building where I'm in, naturally ventilated building, working with CFD analysis, understanding how the building is really behaving over time in different circumstances. Work we were able to do with our colleagues in mechanical engineering. A few years ago, we built a facility lifecycle 4D modeling tool where we realized we actually need to be able to attach multiple schedules at multiple physical and temporal scales into a 4D model. Because some data existed, like temperature data over time, existed at sort of the whole project level. Data about cracks and inspection reports existed at the element level and at final temporal scale. So the ability to connect multiple time-based data sets at multiple levels in the 3D model really allowed us to we tried this on bridges for Caltrans, it allowed us to take a 130-page report and put it all into one model that just navigate and access all this information. And as helpful as 4D modeling is, and we've definitely seen, what we found is really the biggest impact is when you bring this visualization to a group of experienced people and they can work with it. So that it's really, in my experience, important to create these visualizations as quickly as possible. And this was challenging, for example, on this project in Doha, Qatar, the Carnegie Mellon University campus there. It was a very complex finishing phase. Okay, not as complex as Andy's nuclear power plant, but it's a baby version of that, but still pretty complex. 210 rooms per floor, 12 types of crews, 20 operations per room. It was really difficult to create a look-ahead schedule that gave every crew every day work to do. Well, that wasn't easy, that wasn't hard, but to make a productive schedule with good workflow that moved the project forward, etc. That was difficult. And so that's what we wanted to do, help the project with. And to do that, we realized we had to abstract the work in each room into what we called fragments. Basically, we created, I think, something like 20 fragments, which basically represented how the work in each room was going to be done. And then the computer could now put this puzzle together. Given resource availability, given prior work, it could select where to put a crew on a particular day in a particular room. And then it would basically play out a schedule, create one, analyze it, how good is it, and then create another one. So we would, the computer can easily create 10,000 versions of the schedule and see which one is the best. By hand, you can't do it. But if you formalize things in a way like we did, then the computer can help you, and you can actually find the best schedule, and you can rapidly reschedule when a situation changes. A crew is faster, a crew is slower, a crew doesn't show up, what have you. In this way, we're able to find what is the cheapest schedule versus the fastest schedule. They were pretty close to each other, but different. We were able to test heuristics like is it better to work in as many locations as possible, or is it better to keep the crews as busy as possible? On that project, at least, it was better to work in keep the crews as busy as possible, because There was less variance in a good solution, which is to the left of the graph on the right, versus if you look at using the heuristic of working in as many locations as possible, you have some low-cost schedules to the left, but you also have some high-cost schedules on the left, towards the more efficient schedules. So this worked pretty well at the room level, but on projects that are not, or on phases that are not yet at the room level, this wouldn't work so well. So we developed, and some of you have seen this work in other venues where I presented, but basically what we started to look at the space utilization on site. And what we found, at least in the Netherlands and the US, in California, maybe we are particularly bad, is, for example, in the mechanical electrical piping phases, we typically use 3 to 4% of the available workspace to do work. It is really stunning. I'm curious what data you have, but this is the data we saw. And so we realized, what we developed then is a tool that allows you to represent each work as a chunk of basically a crew doing work on an element needing this much workspace. And now the computer can put this puzzle together, again, creating thousands and thousands of works with the schedule so that you can find the most optimal one. So I think with a little bit of formalization, we've seen we can automate the production of schedules quite easily. So we started to also look into data analytics, wondering can we learn something about activity projects from, say, last planner data. We couldn't because the activities are bunching too much information together, too many factors, and we couldn't isolate them. So this led us to a current research project that's going on to create an app that allows you to manage the flows of the work on site. Because in the lean literature, they tell you you should manage activities and you should manage the flows. I'll explain the flows of labor, the flows of workspaces, the flows of equipment, the flows of information materials. So one of my PhD students, Nelly, put this app together. First project we were able to test it was on a 32-story building in Lima, Peru, that used extremely good planning approaches. They had master schedule, task plan, lookup plan, daily plan. They gave each crew, the location of the work every day, every hour. So it was extremely well planned. And so we added to that the ability to track the flows. Basically what this does, it opens up this relationship between activities and says, why is there a relationship? Oh, the next activity needs the workspace that this activity is using, or it needs the crew, or it needs the equipment, or it needs information, what have you. It could be one, or it could be several of these. And by tracking the work on the activities and what the flows are doing, we can get a much finer grained, more easily analyzable picture of construction. And so we were able to, over 18 weeks, collect 415,000 data points with 45 hours of extra work. So the project team felt it was very manageable. And now you can get more insightful feedback on risks ahead because the system cannot tell you why, for example, column work is delayed because you do not have the workspace, is not available. Or the crew is not available from a previous activity, or the information is not available and you have to do now out of sequence work. So this is work going on. In some ways it seems maybe crazy to go to so much detail. In other ways we found that's the only way to really, as best as we can tell, to really use data analytics methods. And finally, we're working on a project, we're working on many more projects, but one more that I want to briefly show is we're working on a project that looks at planning across different temporal scales. And we studied 14 projects as a starting point around the world. And we found a lot of planning at the project and 2-3 months look-at schedule and 1 to 3 week look-at schedule perspective, and also the some at the daily level. But we found surprisingly little integration between BIM and Lean, and we were also pretty surprised by the pretty high unreliability of these schedules. At least these project teams have the data. So here's a project from Germany Each dot represents a BIM element produced. So I thought that was interesting that they were tracking the completion of BIM, so the completion of product, not just the completion of tasks, the completion of products. Again, that's what you get paid for, right? And you can see as the project goes on, the reliability of the schedule gets worse. You also see some gaming from the project team to build things early and report them later. So when we did the data analysis, we realized they built things 8 weeks before, didn't say anybody, so that 8 weeks later they could, this week you don't have a lot of work to report, so they'll report it this week. We also looked at the reliability of the 2-month schedule, and we found that it was, the accuracy really was very low. We found basically 1 in 20 tasks was done according to the schedule in 2 months ago. So, but again, focused on the completion of BIM elements. So the point here I want to make is I think we have an opportunity to collect more data, and I think the tools should give us more data. We shouldn't have to go through this extra analysis method. I think this should come out of the tools. So I'll skip over a few slides because I realize I am out of time. I want to just share one more graphic from another project in South San Francisco, which looks kind of crazy at first, but I think it's actually also quite interesting to learn about our scheduling practices. And this shows on this project in South San Francisco for biotech company, the schedule revisions at the bottom, monthly schedule revisions, and here the dates when work, and here color-coded, on certain systems was scheduled to start. And you can see how some work gets later and later and later. Some work stays reasonably flat, roughly, timing doesn't change. So the majority of things get delayed, some things get advanced. And some things change quite a lot. But this kind of crazy looking diagram at first can actually give you a good sense of how stable the project is. Because you compare this phase of the project with another phase of the project, like you can instantly see a lot more lines moving, a lot more chaos basically in the schedule. So hopefully I've been able to give you a sense of the history of 4D very briefly, show you what we could do in terms of better user interfaces, broader application of 4D, and then also learning from the 4D model and about the planning process. And I think this is fundamental in getting out of this productivity dilemma that we have been in for 50 years, put together by Paul Tycho's, my predecessor at Stanford, basically showing that we have lost 2.5x of value add relative to the manufacturing industry over 50 years. But I think with the methods that you are starting to use or have been using for a while, I think with some of the improvements here, we can achieve this vision that I have, that every work hour safely and productively builds the right product. I mean, at the end of the day, I think this is what we should do, and I look forward to finding out how well we are doing with respect to that over the course of the day. Thank you very much.